Position of the resultant force. Up till now, we have already discussed analytical and graphical methods for determining the magnitude and direction of resultant force of a given system of forces. But in order to know the complete sense of the resultant force, we must know that the position of the resultant, that is generally known as the point through which the resultant force will pass. So for that we have to take one example, and here is that example with P, Q, R and S that is given, and this is one horizontal line PQRS with a total 12 meter long, and the distance between PQ, QR and RS is similar, that is 4 meter, and the different forces are acting at different points. So at P point 1000 kg, Q point 1500 kg, point R 1000 kg and point S 500 kg, and those all the forces are acting at different angles. Now with this system of force, we have to see that what is the actual magnitude of the resultant, and what is the direction, and actually in this force system where it is lying. That is the important task of this solution of this example that we have to cover here. So let us find out the solution of this problem, and the solution of this problem we have to solve with a graphical method. So first of all, from the space diagram we have to generate one vector diagram, and for that we have to select some suitable scale to plot this given forces. So let us start with point A in the vector diagram, and we first of all take 1000 kg as a force, and that force is in a downward direction. So we have to take a scale of 1000 kg, that equals to 1 centimeter here. So we have to plot a 1 centimeter line in a downward direction, and here we have to give a name B to that point. Now by maintaining all the direction of given forces and its particular magnitude, we have to plot a appropriate line with appropriate scale. So second force is of 1500 kg, so we have to plot a 1.5 centimeter line, and we give a name C to this point. After that 1000 kg again, so maintaining that 45 degree, so again 1 centimeter is the length of the line, that is our point D, and last one is again a 30 degree. So here we have to take a 500, that is only a 0.5 centimeter. So this is our point D, and this is our point E that we noted here. Now this is a complete linear vector diagram of given forces. Now using the point E and A, we have to connect that points here. So the connection of those point, that is nothing but a resultant of this given force system. So here we write down that is a R and that is a resultant. Now after that we have to take one point that is called a point O, and that we take appropriately, you can take at any location. So we find out this is the location of point O, and then connect all the line appropriately with point O. So this is line AO, then after line BO, then line CO, DO, and last line that is EO. So this is a completion of a vector diagram here. Now after that we have to plot a actual line in our space diagram. So we start with the AO line. Parallel to that we have to plot one line that is at a point P, and considering that point P and at some farthest location, and here we take a magnitude of that with a vertical line, so that we called a point L, and this one is P1. After that we have to plot a different line parallel to the given forces, so that we plot from the all the point. So these are our parallel line from that forces. After that we have to extend our lines parallel to the AO, BO, CO, DO and EO. So here we have to take AO line, so that is already drawn in form of L P1, then BO line, so that we have to plot here BO line, and then after that is a CO line, and that all lines are connected to each other, and this is a DO line. After that, that is a horizontal line, that is EO. Now we give the name to that particular points. So this is our point P2, this is P3, and this is P4, and last one we give the name M. Now we have to extend that last line and the first line in particular manner. So that line, that is extended in form of a P4M in this particular direction, and first line, that is LP1 in particular direction. So that connects here, and that point we write down, that is our point P. After that we have to take a connection of that first line and last line, and that we are going to connect with the given direction of this resultant force. So that line is connected parallelly here, so that is in this particular direction, and that line is known as a resultant line. Now we have to measure the appropriate dimension of that particular line that gives a value of resultant. Also we have to measure the theta that will make with the horizontal and the length from the point P. So that gives the appropriate location of that resultant of this given force system. So here the overall dimension that is given is 3.9 something. So 3.9, that means the resultant value, that is 3900 kg. This is the value of resultant magnitude. And the angle, if we are going to measure, so that makes the angle with the horizontal, that equals to a 53 degree, and the LP, that is the distance that is measured from the point P, so that equals to 2.2. so that is exactly a 4 and the 2.2. so we take a 2 is equal to a 4 meter in our scale, so it is a 4.1 meter from point P. So this is all about the solution of the given force system, resultant, and appropriate position of that particular resultant.